Welcome. Thank you for coming to our Friday night lecture series. We are very glad that you can join us tonight as we host Professor Philip Ording of Sarah Lawrence College and the Pratt Institute for a talk on the pleasure of the mathematical text. Professor Ording is author of the award-winning book 99 Variations on a Proof and co-editor of Simplicity, Ideals of Practice in Mathematics and the Arts. His teaching, research, and writing explore the aesthetic, literary, and philosophical dimensions of mathematics. 99 Variations, for instance, guides the reader through 99 different proofs of the solution to a third-degree equation, each illuminating not just what one might call a different idea, but a different way or style or disposition of thought. To give you a sense of the varieties of proof, they include wordless, arborescent, paranoid, origami, electrostatic, and omitted. As you can tell, it is a uniquely imaginative book and one that speaks to us at St. John's, given our aim to study mathematics as a liberal art. By this I mean not as a specialized discipline, but as a practice that is available to all and an experience whose enjoyment, like that of art, music, or philosophy, is fundamental to being human. Our students are familiar with the pleasure of the mathematical text and the pain of the mathematical text and the live encounter that makes the mathematical text a ground and a playground for thought. We are grateful to Professor Ording for his visit and for leading us further in this inquiry. Please join me in giving him a warm welcome. Thank you.
Thank you all for being here. Can you hear me okay? Yeah. I also want to thank the Dean, Sarah Davis, and Guillermo, and the lecture committee for the invitation, open invitation to speak about mathematics with you, and also to Verona Tucker for patiently coordinating my visit here. The poet Anne Carson, who makes her living teaching ancient Greek, begins Variations on the Right to Remain Silent by quoting the composer John Cage. Each something is a celebration of the nothing that supports it. Carson's essay is about the role of silence in the practice and study of translation, especially what she calls, quote, metaphysical silence. This is the silence of the untranslatable. For example, the French word cliché, adopted as is by English, the word captures the sound that a solid plate of type metal, a stereotype, makes when it's cast from a type pattern. And Carson adds, we English speakers prefer the untranslated onomatopoeia because a word of French makes us sound more intelligent. But her real interest lies in the metaphysical silence of words at the boundary of language, words that resist translation by design. Her examples here are perhaps by necessity more esoteric, including the name Homer records that Hermes had for the medicine he gives Odysseus in the 10th book of the Odyssey, the guiding voices that spoke to the patron saint of France, Joan of Arc, and the essence of things that the Irish-born painter Francis Bacon sought to paint, what he referred to as, quote, the brutality of fact. By facts, she explains, Bacon doesn't mean to make a copy of the subject as a photograph would, this is a quote from Carson's essay, but rather to create a sensible form that will translate directly to your nervous system the same sensation as the subject. He wants to paint the sensation of a jet of water, that very jar on the nerves. Everything else is cliche. Everything else is the same old story of how St. Michael and St. Margaret and St. Catherine came in the door with 1,000 angels around them, and a sweet smell filled the room. He hates all that storytelling, all that illustration. He'll do anything to deflect or disrupt the boredom of storytelling, including smudge the canvas with sponges or throw paint at it. What emerges for me in reading Carson's essay, beyond a deepening appreciation for the generosity of her intellect, is that her defense isn't as much for the right to remain silent as it is for the freedom to speak without saying anything. To evade a story by short-circuiting narrative with all its meanings and explainings. That jar on the nerves that Bacon aspired to achieve in Paint, by the way, is a phrase Carson borrows to describe Joan of Arc's perception of, quote, an experienced fact so large and real it had solidified in her as a sort of sensed abstraction. What Virginia Woolf once called, quote, that very jar on the nerves before it has been made anything. The attraction of the untranslatable is, it seems, closely related to a desire for a signal free of noise, a form of telepathy, a divine language. Each of these desires has at one time or another characterized the freedom to speak without saying anything that's been cultivated by the practice and study of mathematics. The something that John Cage found to celebrate nothing in his most famous composition, 433, is number. The published edition is a 3-part score that reads simply 1 tacit, 2 tacit, 3 tacit, followed by a non-committal note that reads, the title of this piece is the total length in minutes and seconds of its performance. However, the work may last any length of time. When I asked the mathematician and composer Spencer Gerhardt what was the significance of the particular duration of 4 minutes and 33 seconds, he said Cage would claim to have composed the piece to sell it to the Muzak company, and that 4.5 minutes was, maybe still is, the duration of the Platonic ideal of elevator music. Following Cage and Carson's lead, and that of another of your lecturers from New York City who I heard spoke with you about Gorgeous Nothings, I have 3 readings to share in the spirit of speaking without saying anything. But before turning to my 3 tacits, I want to give you an example to persuade you that my intention isn't to draw you away from meaning into some nihilist data endgame. It's true that there's enough of that going on around anyway. It's true that there was a formative period in my life spent listening to minimal music on repeat, later moonlighting for minimalist artists, and devoutly following the Church of Judson, for all of which I maintain ardent affections. But to the point, after writing the book that Guillermo so beautifully introduced in his marks, better than I can, I felt a deep sense of betrayal, especially at the realization that of all the 99 proofs, the one that stuck in my memory was arguably the most narrative. That frustration led me to study creative writing and the force of stories more generally. And in the course of doing so, I began to see mathematical moves in the workings of texts that couldn't be further from the austerity of so-called minimalism. So, take the 4th book of The Nature of Things, where Lucretius, I put this on the handout, turns from things in themselves to their images. In an extended passage on mirror images, he makes the following argument. Now the reason in a mirror that the body's right-hand side appears on the left is that when oncoming images collide with the flat plane of the mirror, they're not safely turned around, but rather they're dashed directly backwards and rebound, just as if someone took, before it dried, a mask of clay and dashed it against a beam or post. At once its shape would stay just as it was in front, but pressed in relief behind. So the eye, once on the right, is on the left now, and we find the left eye on the right. They've switched places with each other. Okay, like any scientific text, the passage aims here to explain, make sense of experience, resolve problems, or answer questions about the world we're in. Why, for example, the word ambulance is written backwards on the front of an ambulance, how you can see what the barber did to the back of your head, and so forth. Let's suppose, though, that the mathematical content of the passage is the left-right orientation reversing nature of a mirror image. Lucretius has deduced this property from two others, one of images and another of mirrors. It's the nature of images to be composed of parts. In this case, for example, the body's left and right-hand sides. And it's the nature of mirrors to reflect the parts of an image independently of each other. The Euclidean reading I'm giving here traces meaning in logical flow lines running vertically between root axioms and flowering propositions above. For Lucretius, the founding principle, I suppose, is the axiomatic nature of matter, all matter, a quality that images, what he calls matter's skin or bark, seem to inherit. But there are other axes of meaning. The most immediate experience of reading Lucretius is that the nature of things is a poem. There's a delightful orthogonal axis of meaning. It's not always delightful, sometimes it's terrifying, of meaning making throughout De Rerum Natura. The author defends his verses as a necessary additive, a quote, sweet honey of the muse, to coat the bitter pill of his philosophy. But the poem's poetic qualities go beyond dactylic hexameter, the Latin meter that Stalling's translation renders into rhyming couplets. The text is also rich in metaphor. I went back to reading, or I read for the first time, The Nature of Things, partly because there were other authors that wrote about it, especially Italo Calvino in his memos for the next millennium, 6 memos for the next millennium. But also as a way to, after the good advice of one of my writing teachers, Joanne Beard at Sarah Lawrence, to look to metaphors for the place of meaning. And scientists maybe think about metaphor in an expanded way. I'll talk about that later, but in Lucretius, metaphors are alive in the way that we read metaphors in poetry and in literature. So it's kind of thrilling to read that in that way and find all of these. So that's why I was reading. It wasn't on my reading list, though I hear it's on yours. Lucretius, so he introduces images with a succession of vividly observed examples, ranging from the odor that lingers on the hand that handles wormwood, to the birth sack in which calves are born, to the, quote, shiny shirts discarded by cicadas in summertime. Notice how Lucretius puts to use the mask of clay in his argument about mirror images. It functions as a diagram would in Greek mathematics. In place of points, the mask has eyes, and in place of congruence, its soft clay is pressed in relief. How is it that as readers we tolerate this abstraction? If you think about it, it's an image of an image. I think it's because it's more than metaphor, it's an operational analogy. Or in the mathematical jargon, it's an isomorphism. Poetics, and I'm really not sure that's the right word here, like the ones that Lucretius uses, cannot be easily categorized along lines of style versus content, or for that matter, art versus science, because in the course of reading, they structure our thinking. Thanks for bearing with me while I'm contending with some seasonal allergies here. Okay, my lecture will go completely tacit if I don't pause for water, I suppose. Tacit 1. So if you turn on to the back of the handout, there's a diagram. I'm curious if any of you have seen this before, any of these, maybe online or in a poster or in your dreams or on the floor or somewhere. I was very lucky in that my mother brought me to the library on a regular basis from a young age. First for story time in the Minnesota Village where I was born, and later in the sprawling networked Minuteman library system of Massachusetts, where we moved shortly before I started elementary school. The home library, however, belonged to my father, and like his set of woodworking tools, was for safekeeping, mostly out of reach. To his credit, though, he brought me to see Widener Library and explained its borrowing system while he was a complet grad student at Harvard. My 11th grade public high school English teacher, Bonnie Retman, organized a class trip to the JFK Library, where we got to see drafts of the Hemingway Archive novel, in the Hemingway Archive of the novel we were reading in class. In university, I read, or maybe browsed is more accurate, as promiscuously as I could. I remember encountering this diagram on the handout, reproduced in an otherwise ugly book of geometry. The caption declared it to be a representation of the sum total of all 17 possible repeating patterns in the plane. In its details, specificity, oddly gratuitous notation, and intricacy are no less striking to me 20 years later. I think your tutor Guillermo can trace better than I could the line between Lucretius via the astronomer Johannes Kepler and his New Year's gift to this 1924 paper entitled On the Analog of Crystallographic Symmetry in the Plane. The author, Hungarian-American mathematician George Polya, liked to say he was, quote, too good for philosophy and not good enough for physics. Mathematics is in between. So he described a lot of things outside of pure mathematical research, including what the intelligent readers encounter with Euclid is, which I should share with you, those of you who are reading Euclid. In very candid terms, he says that anyone, even if they're convinced of the logical security attained by its deductive method and the logical order from axioms to proofs to propositions, is left wondering how on earth anybody would discover these results, about which Euclid is entirely silent. So he acknowledged that there's this whole world that's happening silently, and it's not expressed in the standard, what Giancarlo Rota, philosopher and mathematician and philosopher of mathematics, would say is the conventional style. Polya researched and revived a study of method, which he credited the origin to Pappus. He calls them heuristics. And among his other publications, Polya wrote a book of problems. It was a 2-volume introduction to, you could call, advanced calculus that consists entirely of problems, which was really unusual. I mean, this is not like Sham's outline or maybe a study guide. It's a proper book that takes you through the deepest results, but only through problems that are carefully sequenced and solved in the back. He co-wrote that with his Hungarian colleague, Zsego. The first problem they start with is, how many ways can you break $1 into change? It's more than you'd expect, even if you exclude the half dollars and whole dollar coins that he counted. I think it's 242. So what about this diagram? Even a lettered diagram, I think you can argue, is always tacit. There's no beginning, middle, or end to it. Geometry speaks volumes, it remains dumb. Of course, the article that Polya wrote that includes the diagram, brief as it is, says something about how and why the diagrams were constructed the way they were. Curiously, however, Polya decides to omit the proof, preferring to cite a standard text on groups and symmetry, whose methods anyone can apply, he claims, to deduce the classification for themselves. As for his own proof, he excuses its absence on account of it, quote, not appearing sufficiently rounded to him. For Polya, this desired roundedness was a deep motivation related to his research into problem solving. So I'm going to read a quote that is, it comes from, I think I am remembering correctly, the second volume of Mathematical Discovery that he wrote decades later. It happened about 50 years ago. When I was a student, I had to explain an elementary problem of solid geometry to a boy who was preparing for an examination, but I lost the thread and got stuck. I could have kicked myself that I failed such a simple task and sat down the next evening to work through the solution so thoroughly that I shall never forget it, trying to see intuitively the natural progression of the solution and the concatenation of the essential ideas involved. I arrived eventually at a geometric representation of the problem-solving process. This was my first discovery and the beginning of my lifelong interest in problem solving. I'm going to skip over a little bit. He says, at any rate, there's an extensive family of this is good. I think it's worth it. The book is actually worth having in the library if it isn't already. The end papers have his geometric representation of the abstract process of solving a geometry problem, which is a kind of wonderful mask of the argument that I think is the same one that he memorized decades ago, before he's writing this. Okay, I was guided to the geometric image that finally emerged by a group of unusual metaphorical expressions, that the language is full of metaphors, dead, half-dead, and live, has been observed often enough. I do not know whether it has also been observed that many of these metaphors are interdependent. They're connected. They're associated, and they form clusters more or less loose, more or less overlapping families. At any rate, there's an extensive family of metaphorical expressions which have two things in common. They're all concerned with the basic human activity of problem solving, and they are all suggesting the same geometric configurations. Discovering the solution is finding a connection between formerly separated things or ideas, the things we have and the things we want, the data and the unknown, the hypothesis and the conclusion. The farther apart the things connected stood originally, the more credit is due to the discoverer for connecting them. Okay, I want to take a break from talking. I'm going to try to play for you some poetry. This is, if I can get it to work. If you're like me and don't read Danish, the poet Inger Christensen is reading the first 5 pages of her book-length poem, Alphabet, from 1981. That's been translated by Susanna Need in the handout. So this tacit maybe lasts 90 seconds.
Aprikostræerne findes, aprikostræerne findes, bregnerne findes, og brumbær, brom findes, og brinten. Cikaderne findes, cikorie, krom og citrontræer findes, cikaderne findes, cikaderne, ceder, cypres, cerebellum. Duerne findes, drømmerne, dukkerne, dræberne findes, duerne, dis, dioxin og dagene findes, dagene, døden, og digtene findes, digtene, dagene, døden. Efteråret findes, eftersmagen og eftertanken findes, og enrummet findes, englene, enkerne og elstyret findes, enkelthederne findes, erindringens lys, og efterlyset findes, egetræet og elmetræet findes, og enebærbusken, ensheden, ensomheden findes, og edderfuglen og edderkoppen findes, og eddiken findes, og eftertiden.
Christensen describes one of her desires is to write in the quiet stream of sounds prior to language. I think of this as very different than what Polly is writing about, but no less mathematical. About an earlier, longer poem, Det, which translates to it, she said, quote, "If I could start in total silence, slip into the stream." Does it sound okay? Okay. If I could start in total silence, slip into the first sentence, hide there as in water flowing, go on until the first little ripples appeared, almost words, almost sentences, more and more. The mathematical structure of alphabet is more overt. I'm not sure if this note accompanied the first edition, but both the Danish and English editions cite Fibonacci, which you might have noticed. The number of lines in one page to the next increases like the Fibonacci sequence. Interestingly, I learned from a lecture by the number theorist Manjul Bhargava that the recursive sequence A of n equal to 1, 2, 3, 5, 8, and so forth, up to A of n minus 2 plus A of n minus 1, the sum of its preceding 2 terms, and going on, originated a millennium before the Italian mathematician Leonardo Bonacci lived, by Sanskrit poets, actually. The sequence arises as the solution to a much more natural problem than spawning rabbits, which you might have heard as Fibonacci's problem that he states the numbers as a solution to. In Sanskrit prosody, which concerns a quantitative metric verse, among other things, in which accented syllables are twice as long as unaccented syllables. So the nth number in the sequence counts the number of ways one can divide a line of n beats into sequences of light and heavy syllables. If n is 1, there's only one option, just a single light. If n is 2, then you could have 2 lights or 1 long, heavy. If n is 3, you could have 3 shorts, 1 short and then a long, or 1 long and then a short, and so forth. I wonder if Carson had Christensen in mind when she wrote her essay on the, quote, maddening attraction of the untranslatable. Susanna Need's translation of Det is actually introduced by an essay Carson published in American Poetry Review, where she associates the book with Theogony, an epic poem by the 8th century poet Hesiod. Both Theogony and Det Carson identifies as cosmogonies, which she helpfully defines as accounts of the birth of things out of nothing, in contrast with cosmologies, systems by which things make sense to us. All right, tacit 3. That there could be pleasure, even bliss, in cosmogony, let alone a mathematical one, might seem preposterous for reasons that are obvious, but I'm glad that Guillermo emphasized. For those of us who actually read mathematics and try to understand it. But I've adapted the title of this talk from the French philosopher Roland Barthes' The Pleasure of the Text, which really has nothing to do with beach reading. Here's a passage which I think comes the closest to saying what he finds pleasurable in the text. He says, the text, it produces in me the best pleasure of it if it manages to make itself heard indirectly. If reading it, I am led to look up often, to listen to something else. I'm not necessarily captivated by the text of pleasure. It can be an act that is slight, complex, tenuous, almost scatterbrained, a sudden movement of the head, like a bird who understands nothing of what we hear, who hears what we do not understand. It seems impossible to remember one's first personal encounter with the cosmographic potential of language or mathematics. I remember trying to read an algebra book on the back seat of the family car on a cross-country visit back to Minnesota. A precocious friend of mine put the idea in my head that if I somehow learned algebra over the summer, I could join him in a geometry tutorial that the math coordinator of the school system had planned for him. I'd learned with my less distinguished classmates how to find the number redacted from the simple equations that filled our pre-algebra worksheets. This book, however, it was hardbound and resembled something closer to the New Testament than a workbook. Even though it had several pages of the same linear equations I'd learned to solve before, it started out with more fine print than a pharmaceutical ad. And once I understood that these were the rules of algebra, an idea took hold that mathematics, all of it, might be nothing more than a game governed by a finite set of rules. I think the reason I thought of it as a game, now that I read this, is that my teacher, Miss Peterson, in 7th grade, gave us over winter break the puzzle to take the year, and I don't remember what year it was now. I could work it out, but I'll spare you. And try to express as many numbers from 1 on to 100, say, using just the digits in the year and all the arithmetical operations, including a new one she taught us at the time, which was factorial. And it was I think it was the first time I'd ever encountered an open-ended problem. And I remembered that there were friends of mine who were positioned in the back of the class for various reasons, who actually got excited about this, and friends who were on my soccer team, who we had something to talk about with. So this idea that actually all of mathematics might be this open-ended game dawned on me. Of course, these rules were presented abstractly, without actual numbers. At the time, I couldn't see that the author likely intended that fine print simply as a reminder to the instructor, not the students. To me, it seemed one had to have already played the game to know what the rules meant. For many years, it felt like a personal failing that this impression of mathematical cosmogony that didn't prompt me to actually learn to do algebra that summer. What happened instead is that I lifted my eyes from the first page and watched the landscape outside the windows pass by. By the time September came around, Mr. Davis determined on the basis of a brief diagnostic quiz that, truthfully, for better or worse, my understanding of algebra would benefit from the usual course of study, and my friend went on to geometry with him without me. The Russian-born British mathematician and education scholar Alexander Borovik has been collecting testimonies like this from his research acquaintances for many years now. He noticed that while the experiences he solicited are often quite commonplace in that they could happen to almost anyone, it tends to be mostly individuals who pursue a mathematical science into adulthood who manage to remember such encounters in any detail. He published a selection of these testimonies, as he calls them, in a chapter of a book titled Understanding Emotions in Mathematical Thinking and Learning, edited by Ulysses Xolocotzin-Eligio in 2017. The episodes in that chapter are scattered among ages from 3 to 23. Most of the testimonies in the chapter, which Borovik titled Being in Control, are anonymous. But the author of the example I've reproduced in the handout allows herself to be identified as Yagmur Denizhan, and Borovik notes that she's a Turkish professor of electrical engineering at a leading Turkish university. There's a lot more to explore across these mathematical ways of meaning making. One could sum up with a naive geometry of a three-dimensional space of the pleasure of the mathematical text, maybe the problematics that grade the landscape of the mathematical sciences brought to light by Polya's keen observation of mathematical practice running that way, and the deductive pattern that accumulates meaning in a framework of cosmogenic axiomatics going in another direction, and the metaphors by which such texts manage to resonate in one's mind in some other orthogonal direction. Instead of doing that, though, I'm going to give some excerpts from a collage of Polya and Borovik's work that my friends Brian O'Connell and Deirdre O'Dwyer are helping me assemble at their Los Angeles press, Rakish Light. When I was 3, my mother pushed my baby cart and me to a store. At the time, prices were given by little plastic numbers below the item. When we got home, my clothes revealed lots of plastic numbers. My mother made me return them. Probably I was 4 years old when my mother still forced me to go to bed after lunch for a while and have a little nap, a little sleep. Children don't need this rest after lunch, but parents need children's sleep. Quite often I couldn't sleep and made some calculations with small integers to entertain myself, and afterwards I presented the results to my mother. Soon I didn't restrict myself to addition, and invented by myself other arithmetic operations. Unfortunately, I don't remember which, probably minus, but I invented also a name for it, of course not the usual one. I don't remember which name, but I remember that my mother reconstructed from my results what operation I had in mind and told me what I did in official terminology. So I forget my own words for it, but I had a new toy for the siesta time. The wallpaper near my crib had been put up in a very careless way. I remember when I was around 4 or 5 years old, I got up every morning in a bad mood because of this. Every morning, I tried to move some parts of the wallpaper in my mind. However, after some time, 2 to 3 years, I got used to seeing inexact patterns. Sometime later, I could even imagine the whole plane covered by the wallpaper. However, not in a perfect way, but in the way that it looked around my crib. That is, I think I had found a certain shape on the wallpaper near my crib that could be used to tessellate the whole plane. Of course, this shape contains some inaccuracies. I started thinking about death and wanted to convince myself I'd never die. Instead of thinking about life after death. So I started thinking about an infinity in this way. First, I assumed that my entire life was only one dream in one night, in another life, where I am still the same person, but could not fully realize that a full life goes on in each dream. An interesting point about personal identity, I guess. Now that other life would be finite and have only a finite number of nights. So I thought further that in each night there must be a finite number of dreams, encapsulating a finite number of lives. This was still short of infinity, so I started thinking that in each of these finitely many dreams, of the finitely many nights, I'd live a life that would in turn contain finitely many nights, which would contain finitely many dreams, and so on. I wasn't sure that I was safe that way, but I would go on living forever, but I convinced myself that these were enough lives to live. Even if the process would end, I'd still have lived enough. I stopped thinking about it. Although I obviously knew the word before my real encounter with and comprehension of the concept of, quote, taming, it's connected with my reading of The Little Prince. As far as I can figure out, I must have been nearly 12 years old. Saint-Exupéry offered me a good framework for my potential critiques of the world of grown-ups that I was going to enter. I also must have embraced the concept of taming so readily that it became part of my inner language. Some years ago, a friend of mine told me of a scene from our university years. One day, when he entered the canteen, he saw me sitting at a table with notebooks spread out in front of me, but seemingly doing nothing. He asked me what I was doing, and I said, though I don't remember having said it, it sounds very much like me, I am taming the formula. My personal evaluation of myself is that as a child, till 8, 9, I was intellectually better off than when I was at 14, sorry. At 14, 15, I became interested in math. It took me about 20 years to regain my 7-year-old child perceptiveness. All right, this is the last one. The landlady hurried into the backyard, put the mousetrap on the ground. It was an old-fashioned trap, a cage with a trap door, and called to her daughter to fetch the cat. The mouse in the trap seemed to understand the gist of these proceedings. He raced frantically in the cage, threw himself violently against the bars, now on this side and then on the other, and in the last moment he succeeded in squeezing himself through and disappeared in the neighbor's field. There must have been on that side one slightly wider opening between the bars of the mousetrap. The landlady looked disappointed, and so did the cat, who arrived too late. My sympathy from the beginning was with the mouse, and so I found it difficult to say something polite to the landlady or to the cat, but I silently congratulated the mouse. Thank you.